Hello, this is a little recording of a presentation that I came up with for some of my cycling friends. And it's all about what you can do with low-carb training principles. And by low-carb training principles, I'm talking more about how you train and less about what your base diet is, although there is some impact of your base diet as well. And I got interested in this as I got older and found that even with a bunch of cycling and trying to eat what I thought was a healthy diet, I started putting on weight and just started getting heavier. And I also had some energy problems. So I dove into a bunch of biochemistry and physiology and kind of realized that things were a lot more complicated than I thought. And that's where this talk kind of comes from. And part of this started back in 2016 when I came across this picture. And this is a tweet from pro cyclist Chris Froome during the Tour de France held in 2016. And the title says, Rest Day Breakfast. And so Tour de France typically runs 12, 13, 14 days. And they will have 2 days typically that are rest days. Now, rest days are a bit of a misnomer. What it means is instead of going out and cycling very hard for 4 or 5 hours, they will go on a relatively easy ride for 2 or 3 hours, simply because that's better for them from a recovery perspective. So this is what he ate on one of his recovery days. And we see there are four poached eggs. Looks like half of an avocado, some amount of fish, and then that performance cherry thing is a little drink mix. So you add that to water, and that's what you drink. So I was curious, and I just went and tried to do some nutritional analysis on this, and here's what I came up with. So about 116 calories come from carbohydrate, and that's almost all from that performance cherry drink. About 116 calories from protein and about 400 calories from fat. So what we would see is this is a very fat-dominated breakfast. And this clearly goes against at least what is conventional wisdom about nutrition for athletes. And it clearly didn't hurt Chris Froome that year, since this was one of the years he in fact won the Tour de France. So what do I mean by low-carb training? So low-carb training is training in scenarios where glucose availability is limited. And the goal of the training is to maximize the ability of the muscles to burn fat instead of glucose. And why do we care? What might we get out of it? Well, one of the main things is better endurance and easier fueling for long events. If you can burn more fat, the glucose that you have in your glycogen stores will last longer. And that means you are less dependent on eating during your ride or whatever other event you're doing. The second benefit is you can improve your body composition, which is the kind of nice way of saying you can lose weight. Generally speaking, fat burned during exercise is something that your body really doesn't feel the need to replace. Whereas if you burn a bunch of glucose, your glycogen stores get low, and that tends to drive your hunger so that you eat back the calories you burned. And finally, there can be some improved metabolic health outcomes. Perhaps surprisingly, even athletes can get insulin resistant, and they can also even get type 2 diabetes while they are actively training athletes. So to understand what's going on with this low-carb training, I need to go a little bit into physiology and biochemistry. You do not have to know all the details here, but you do kind of need to understand the overall model. And I'm going to start by talking about fat metabolism and glucose metabolism and how they are similar and how they are different. So we start with fat metabolism. The stored fat we have breaks down into fatty acids, and then it goes into this process called beta oxidation. And beta oxidation yields a little bit of ATP. And you've probably heard of ATP. You can think of that as the energy transfer mechanism to take you from energy in a food molecule to energy that your muscles can actually use. So the ATP is created and the actual molecules go over to your muscle fiber and kind of latch on, and the energy in the ATP is used to cause the muscle fiber to contract. So that is kind of what is driving our muscles in exercise. So as a byproduct of beta oxidation, we get another compound called acetyl coenzyme A, usually just referred to as acetyl-CoA. And you can think of this as an intermediate energy compound. And that's going to feed into another process known as the citric acid cycle, also known as the TCA cycle or Krebs cycle, depending on when you learned and which biochemistry book you had. And that generates more ATP that can go to your muscles. And then at this point, we end up pretty much just with carbon dioxide and some water left over from the cycle. So that's what happens for fat. Now, looking at glucose. Glucose first goes through this process called glycolysis that generates a little ATP, creates an intermediate known as pyruvate. That goes into pyruvate oxidation, generates a little more ATP, and once again generates acetyl-CoA, and then that feeds into the citric acid cycle. The same way the acetyl-CoA from fat metabolism feeds into the citric acid cycle. So if we put these side by side, we see something that's actually kind of interesting. We have two separate pathways for getting energy. We can go down the glucose pathway, or we can go down the fatty acid pathway. Now, the boxes in green and the big box around indicate that these operations are aerobic. And by aerobic, I mean they require oxygen. So what that means is one of the things we will be inherently limited with when we're trying to do this is how much oxygen we can get to the parts of the muscle cells that perform these operations. And in fact, if you remember biology, you may have had this in the past, cells have mitochondria in them, and mitochondria is where these green operations happen. And I like to refer to this as the base aerobic system. If you're going out and you're not working out very hard, you're going on a long run at an easy pace or a really long bike ride, or you're just walking or gardening, anything like that, your energy is coming from your base aerobic system. To quantify this, I'd call it an easy effort. If you do training based on zones, either with heart rate or power, I would call this zone 2 training or below. So zone 1 or zone 2 training. Now there's this interesting other part that is specific to glucose. And I have that highlighted in pink now. And the interesting part is this process of going from glucose through glycolysis to pyruvate is not in the aerobic zone or in the aerobic box, because it actually doesn't require oxygen. And in fact, it actually doesn't happen inside the mitochondria. It happens just in the muscle cell. So this looks really interesting. So if we've run out of ability to do things with oxygen, say we don't have enough oxygen to get to the cell, or the cell simply cannot process either the pyruvate or the fatty acids quickly enough, or I guess the citric acid quickly enough, it would be nice to have another way to get energy. So glycolysis looks interesting. We can take glucose and we can just run it through glycolysis and we get pyruvate, and that gives us ATP. and that ATP is not dependent on oxygen. So that looks really great. But we have a problem. If we do that, we accumulate a lot of excess pyruvate, and that pyruvate poisons the reaction, the glycolysis reaction, so it just stops. So what we need is a way to do something with that pyruvate. And it turns out we can take pyruvate and convert it to another compound called lactate, which you've probably heard of. And then that lactate can be shipped out of the muscle cells into the bloodstream and then taken up and processed by other tissues. So you can think of what's going on is the muscle cell is doing glycolysis and it's sending the lactate out to the blood, and then some other tissues, either other muscles that have enough oxygen or just other tissues that have enough oxygen, will complete the process through pyruvate oxidation and citric acid cycle. So this is a really interesting hack from a biochemistry perspective or physiology perspective. It's a way that our muscles can get more energy kind of than they should be able to through the aerobic system. The big thing that controls how well this works is what we usually call lactate clearance. And that's simply how fast we can get the lactate out of the muscle cells into the bloodstream and then processed by other tissues. And it turns out that at higher efforts, the amount of power you can produce is really dependent on how well you can clear the lactate out. And it's also dependent on how tolerant you are of the side effects of excess lactate. So excess lactate in the muscles is what makes your muscles hurt. And there's some decent evidence that good athletes or top athletes are actually just better at tolerating high levels of lactate. So I would call this the lactate system. It's often called the anaerobic system, which I think is a little confusing. Yes, the first step is anaerobic in the muscles, but then it's aerobic afterwards. So I think the lactate system is a better name. So that's basically what's going on. And the lactate system is the high power system. The base aerobic system is the low power system. So from the perspective of training, and especially from the perspective of trying to burn more fat, we can kind of ignore the lactate system because it only burns glucose. So we're going to look at the base aerobic system and talk about what drives the choice of fuels. So we have these two parallel pathways, the glucose pathway and the fatty acid pathway. And how does the body choose between the two? Well, if I remember what I used to believe about sports nutrition and the way I used to eat, this is the kind of stuff I would eat. So I'd eat a base diet with pasta and bread and fruit and all of the healthy athlete sort of things. And then I would supplement with some of the specific for athlete nutritional supplements. And some of these are high in glucose. Some of these are also high in sugar as well. And what does this mean? Well, when I eat those sorts of things and I go and train, I end up with high glucose. And what does that mean from the physiology standpoint? Well, what it means is my body is always high in glucose. It's going to be going down the glucose pathway because it's just simply trying to burn up the glucose that it has. And I will end up being trained to be quite good at this pathway. And I'll end up being untrained on the fatty acid pathway. What does this lead to? Well, the first thing it means is because I'm untrained on the fatty acid pathway and because I have high glucose all the time, it means that I can't effectively burn fat. And it also means that if I don't eat carbs, I'll run out of stored glycogen and bonk if I exercise long enough. What this leads to is a bit of a self-fulfilling prophecy. If you always train on a high glucose diet, you can only perform in exercise on a high glucose diet because your body simply cannot burn the fat. That's really good for the sports nutrition industry because there are all of these different products and they all have really nice profit margins. You know, that container of Accelerate there is about $30 for 2 pounds, and it's probably got maybe 3 pounds, maybe 4 pounds of ingredients in it. You know, it's mostly sugar and whey protein and I think trehalose as well, none of which cost a particularly large amount. So, if we want to become trained on the fatty acid side, how do we need to train? Well, you might have figured this out. We have to train in a low glucose environment. And I hope you figured that out since I already said that at the beginning. So what do I mean by training in a low glucose environment? Well, all I'm talking about is the amount of glucose that is available during a training session. And in my old days, I was what I called a carbs before, during, and after athlete. So I always had a carby snack before I went out and rode my bike, and I always had something carby with me. Typically it was a nutrition drink with carbs in it, and then I'd get back and I'd have another nutrition drink with carbs in it. So what does that mean about my glucose availability? Well, I had a carby meal before, and therefore I started and I had high glucose availability. And then along the way, I'd add more glucose, you know, from whatever I was eating or drinking along the way. Now, eventually, if I was doing something long enough, I'd burn through some of my glycogen stores, kind of get down to a medium level, and then eventually I might get down to a low level. And at that low level, I could finally be training my body to be better at fat burning. But that could take quite a bit of time. Now you notice I have duration labeled on the x-axis, but I don't actually have any numbers there, simply because it's going to depend upon how hard you're working, what carbs you're burning, what you ate before, what you ate during, and just a whole bunch of different factors. But generally speaking, if you had to press me and I had to give some numbers, I was typically doing 2.5 hour rides, and I would guess that I never got out of medium at best on those rides. I don't think I ever got to low. Now, if we wanted this to be better, what's the first thing we'd do? Well, the first thing I'd think about doing is getting rid of the food that I'm eating on the ride. So, same snack before, no food during. What do I see? Well, I progress through these phases much more quickly. And, okay, that just makes obvious sense. I don't stick it high as long because I'm not adding glucose to the glucose I already have. So that gives me more opportunity for getting training in that fat burning zone. And then finally, if I want a little more, I could say no food before, so undo my training fasted. And that would take me from medium to low really pretty quickly. Now, typically, when I'd say fasted training, I'd mean overnight. Like you get up in the morning, you don't eat breakfast, you don't eat anything, and then you go out and train. Technically, if you had lunch and it's now dinner time and you haven't eaten anything, I'm probably going to call that fasted training as well. It may not have quite as much effect, but it's probably going to be pretty close. And then if you want the ultimate, well, you can go on a low-carb diet at the same time. And then, in fact, anytime you go training, you're on low glucose availability. So you can get the best effect the less glucose you start with. However, there's some dragons in these last two approaches. So what happens if you're a carbs before, during, after athlete and you say, hey, I want to go do some fasted training? Well, what happens is your body isn't any good at burning fat. That whole beta oxidation pathway just doesn't work very well. So what happens is you go out, you burn through all your carbs really quickly, and you bonk. And that's really no fun. If you do the same thing, but instead of being fasted, you're on a full low-carb diet, the effect's even worse. The other problem is that you need to be in zone 2 or lower during the time you're trying to increase your fat burning training. Now, you remember when I talked about the base aerobic system? Base aerobic system is zone 2 or lower, and that's the only place where you can burn fat. So if you go out and say, I want to do fasted training, that'd be great, but you go out and do a zone 3 or a zone 4 ride, or you go out and do intervals, and guess what? You're up in the lactate zone. And in fact, the amount of power you get from the base aerobic system is going to be less than it would be otherwise, because your intensity is so high. So you burn through a bunch of glycogen, and you don't get the training effect you would like here. So you really need to be down in zone 2 or lower training rides. And this is probably the hardest thing to do as an athlete. Most of us don't have that much trouble working hard. We have a lot more trouble not working hard. Now, you may have heard of this as base miles. Base miles have been around forever, often known as well as long steady distance or long slow distance. Both of these are concepts that come out of normal structured training approaches. And those longer, slower efforts are particularly targeted towards the base aerobic system. And if you look back at the physiology, you'll understand why. It's like, oh, we're trying to train that base aerobic system, and it only deals with these easier efforts. If we want to train the high-level system, we do different sorts of efforts. We do targeted intervals or repeats or anything that is pushing the lactate clearance, because that's what we want to improve. So my best advice here is that what I want to see is a slow change over time. Don't try to go from a carbs before, during, after athlete to a low-carb athlete all at once. You really will not have any fun. This is what I did because I didn't know all of this when I did the change. And I had one ride, I went out, felt great for 45 minutes. And then after that, I'd burned through all my glycogen. And I honestly wanted to get off my bike and throw it in a ditch. I just had no energy left. And I crawled back. I had probably 20 miles, 25 miles to get home. And I crawled back at about 11 or 12 miles an hour. And that's something that not only is no fun, it really doesn't help you. So what I would generally recommend is if you're having carbs during this, go out and do a long, steady, low intensity ride, and don't eat as many carbs as you normally would. So cut the carbs you'd eat in half, and try that for a while. And then once you're adapted to that, get rid of the carbs totally. And once you're adapted to that, then that's a reasonable time to start the fasted training. My other advice I always give, always carry something carby with you, because it's really easy to make a mistake when you're trying to do these. Either you end up going longer than you expected, or you end up going harder than you expected. My other advice, try not to do this on group rides unless you're all trying to do this, simply because group rides are kind of notorious for not being zone 2 rides. A few special considerations. If you are insulin resistant, and at this point, I hope many of you are saying, how do I know if I'm insulin resistant? And the real answer is, if you really want to know, there's this fun test. You can get your fasting insulin and fasting glucose measured, And then there's this calculation called HOMO-IR, which is pretty good at detecting insulin resistance early. Most people aren't going to do that, so I'll give you a few rules of thumb. If you are pre-diabetic, type 2 diabetic, if your doctor has said anything about, being worried about diabetes, then you are pretty much by definition insulin resistant. If you have significant amounts of excess weight, if you have energy problems, and for me, energy problems meant at lunch at work, I'd go out and I'd get a nice big burrito, big tortilla, lots of rice, lots of beans, lots of other good stuff, and I'd eat it, and then 2 or 3 hours later, I'd fall asleep at my desk, or at least come close to falling asleep at my desk. That's the sort of thing I mean by energy problems. Or if your weight has started to creep up even when you eat clean, and this is pretty typical, especially for older athletes. You may have been fine in your 30s, and then you hit your 40s and get into your 50s, and all of a sudden the way you were eating that used to work isn't really working pretty well. And that's a pretty good sign that you've become more insulin resistant. If you're insulin resistant, fasted training alone may not be enough to see the changes you want. And the reason I put may not is that this has not been researched very well at all. There's a lot of research done about diabetes, type 2 diabetes, because it's a very impactful disease for the people who have it. So lots of studies in that. Very, very little studies about exercise, and especially fasted exercise, and how it relates to type 2 diabetes. So we just do not have the scientific data there. I kind of know what effect I would expect to see, and I expect for many people doing fasted training may be all that they need, and that may in fact work to reverse some insulin resistance. If you have significant insulin resistance, it may not be enough. You may actually need a lower carb diet. And notice I say lower carb diet there. There's this vast range of carb intake amounts between the traditional low-fat, healthy athlete, high-carb diet, and a very low-carb diet like keto. And generally, if you're an active athlete, an endurance athlete, and you care about performance, I think for most people, keto diets are a little too low in carbs. But if you do something, what I'd call a keto adjacent diet, so maybe 50, maybe 75 grams of carbs per day, I think in general that seems to work pretty well for most endurance athletes. Now it's going to depend a ton on what your metabolic state is, what sort of things you do, what sort of rides you do, how long they are, what the intensity is, and it's very likely going to depend on your genetics as well. So that might be required. And that's really all I wanted to talk about. Just wanted to make this a quick introduction. If you want a lot more details, I have a cheap ebook on Amazon you could go and dig up. It talks about the physiology a lot more in much more detail, and gives a lot more references. But I think what I talked about here is probably sufficient for most people. So, thank you for your time.